Today, we're diving into one of the most clever and efficient patterns in all of coding, the two-pointer algorithm. Seriously, this thing is a game changer. It can take code that feels slow and clunky and make it unbelievably fast. So let's see how it actually works. All right, let's set the stage. Imagine you get this question in a coding interview. You've got a list of numbers, it's already sorted, and you need to find two of them that add up to a specific target. Now, what's your first instinct? You could check every single combination, but is there a smarter, much faster way? Let's find out. Before we get to the really slick solution, we have to talk about the most obvious one first, what we call the brute force approach. I mean, it works, it gets the job done, but as you're about to see, it comes with a pretty heavy cost. So what do we mean by brute force? Well, it's exactly what it sounds like. We take the very first number and we add it to every other number in the list to see if we get a match. Then we move to the second number and do the exact same thing, and on, until we've tried every single possible pair. It's definitely thorough, but man, is it repetitive. And this slide really puts that cost into perspective. Brute force has a time complexity of O of n squared. Now, in plain English, that means if your list of numbers gets twice as long, the time it takes to solve it gets 4 times longer. It's like trying to find a winning lottery ticket by checking every single one by hand. The two-pointer method, on the other hand, is just O of n. It's a much more strategic, targeted search. So how do we make that jump to a smarter O of n solution? Well, this is where the hero of our story comes in, the two-pointer technique. It's a completely different way of thinking about the problem. First off, let's demystify this word pointer. It can sound a little intimidating, but in this context, it's actually super simple. A pointer is just a variable we use to keep track of a position, an index, inside our array. That's it. It just points to an element. And this slide really shows you the magic leap. If you use just one pointer, all you can do is track one element at a time. But the moment you add a second pointer, now you can compare elements from two different spots. And based on that comparison, you can make an intelligent decision about what to do next. So here's the absolute key to the whole thing. The two-pointer technique isn't magic. It works because it takes advantage of the data structure. Since our array is sorted, we know for a fact that moving a pointer to the right will always give us a larger number, and moving to the left will give us a smaller one. We use that predictable logic to guide our search intelligently. Now, there are a few common ways to actually move these pointers around. Let's take a quick look at the main strategies before we apply one to our problem. You can see the two main approaches right here. On the left, we've got inward traversal. This is where the pointers start at opposite ends of the array and move towards each other. Then on the right, you've got unidirectional traversal, where they start near each other and move in the same direction. For our specific pair sum problem, that inward traversal is exactly what we need. Okay, enough theory. Let's put this all together and actually solve our original problem. We're going to walk through it step by step using that inward traversal strategy we just talked about. So, we start by placing one pointer, we'll call it left, at the very beginning of the array. And we put another pointer right at the very, very end. Now, we just add the numbers they're pointing at. -5 plus 6 equals 1. Our target is 7, so not quite there yet. Okay, now we have to make a logical choice. Our current sum, 1, is too small. Since we know the array is sorted, how can we make the sum bigger? Well, the only way is to move the left pointer one step to the right, to a larger number. Moving the right pointer would only make our sum even smaller. So, let's check our new sum. -2 plus 6 is 4, still less than our target of 7. The logic is the same. To get a bigger number, we've got to move that left pointer again. Okay, now something different happens. Our current pair, 3 and 6, adds up to 9. This time, our sum is bigger than the target. So what's the logical move now? To get a smaller sum, we have to move the right pointer one step to the left to a smaller number. And there we have it. Our new sum is 3 plus 4, which is exactly 7. That's our target. We found the pair. We did it. And notice how we just elegantly closed in on the answer instead of frantically checking every single combination. That was pretty cool, right? But let's zoom out for a second and really appreciate why this pattern is so important and why it's such a fundamental tool for any programmer to have. This slide just says it all. Brute force gets exponentially slower as your list gets bigger. But the two-pointer approach, we only had to scan through the list once. The pointers only ever moved forward, closing the gap. That's what gives us that beautiful, efficient, linear O of n time. making it so much faster on large amounts of data. So let's just recap the benefits. First, you get incredible speed. O of n is a massive improvement over O of n squared. Second, it's super efficient with memory. We didn't need to create any new arrays or data structures, just two simple variables for our pointers. And finally, it's so versatile. This isn't just for adding numbers. You can use this pattern for all sorts of things, like checking for palindromes or finding duplicates. And if you're thinking this is just a neat trick for coding interviews, think again. This is a real-world, heavy-duty technique. Two-pointer algorithms are at the very heart of things like garbage collection, which is constantly running to manage your computer's memory. A scan pointer and a free pointer work together to clean up and organize memory. It's a powerful pattern running in systems all around us all the time. And that just about wraps it up. We've seen how the two-pointer technique can transform a clunky, brute force search into something fast, logical, and elegant. So the real question I want to leave you with is this. Now that you know how to spot it, where else can you use this powerful pattern in your own code?